Hello, hello. Welcome to another wonderful day of pre-calculus. Today we're going to be talking about factoring, anything and everything that has to do with factoring. So definitely put away those distractions, pull out the notes, and here we go. All right, completely factoring polynomials involves a lot of different methods. We always start off with talking about the greatest common factor and looking for that within our polynomial. Then we check and see, do we have any patterns, a difference of squares, sum of cubes, difference of cubes, perfect square trinomial. Everyone forgets about that one. Then there's also factor by grouping and quadratic trinomial patterns, as it were, when the leading coefficient is 1, and sometimes the leading coefficient isn't 1. So these are all of the different things that we're going to be talking about in today's video. All right, so let's get to it. So first off, we're going to talk about the greatest common factor, also known as the GCF. And whenever we're doing this, we're going to list the factors in each term and find out what factors are common to every term and pull out, as it were, the common factor. So let's get started. So let's say we're looking at our good friend 24y to the fourth minus 54y cubed. So 24, one of the ways that people find out all of their, however it is that you want to go looking for your common factors. So some people make this thing, I've heard it called the cake method, the ladder method. I don't, there's lots of names for this, but you start by dividing prime numbers. So prime numbers on the outside, and then what's left on the inside is after you do the division. Until you get to, at last at the bottom, you find a prime number. So you can only divide by prime numbers, you can't divide by 6 or anything else like that. Other people do use things called factor trees. It again is, so like 54, I know I can divide that by 2. That's going to leave me with 27. Keelan. He's watching a very exciting YouTube video. And he likes to make sound effects. So there we go. So now that we have Keelan. Thank you. All right, so we're going to list these guys out. I've got a 2 times a 2 times a 2 times a 3, and then I have 4 y's. 1, 2, 3, 4. And then we have over here with 54, we have 2 times 3 times 3 times 3 times 3 y's. 1, 2, 3. All right, so now we go looking for things that are common. That's the next thing we're supposed to do. So right here, they both have a 2. So my GCF has a 2. This guy has a second 2, but this one does not, so that's not my next thing. But they do both have a 3, so 2 times 3, and then a y with a y, a y with a y, a y with a y, and that second guy's already run out of y's, so we can't pull out any more y's. So that's going to leave me with 6y cubed, and that is my GCF. So that's the part that I'm pulling out, 6y cubed. So then the next thing I have to wonder about, okay, so that's what I pulled out. What is left with each of my terms? I started this thing off with 2 terms, so I need to make sure that I still have 2 terms down here. My GCF is positive, so I'm going to keep all of the signs the same. The first guy will be positive, then there's a subtraction sign on my second term. So down here, what I have left is 2 2's and a y, so this would be 2 times y, which is 4y, so that's going to be my first term. And then over here, I have a 3 and a 3 left with no y's. So 3 times 3, that gives me 9, and that's what's left in here. So 4y minus 9. So we have 6y cubed on the outside, 4y minus 9 on the inside, and that's the thing. So one thing that happens later on is people are like, but Miss Norton, let's say I had 24, let's see, 24y to the fourth minus 24y squared. And my GCF here is going to be 24y squared. Keelan, I'm going to kick you out of the room if you can't be quiet. So then what's left here is a y squared, but we pulled out all of this. Does that mean that that term just goes away? No. It means that you're left with a minus 1. And that's how you factor out the GCF. Sometimes you got your GCF is one of your terms. Okay, so that's GCFing. Let's move on to our patterns. There's 4 of them. The first pattern that people like to talk about is the difference of squares. This is the one that you're going to see the most often as you're going throughout this course. And the pattern is if I have 2 things that are being squared and I'm subtracting them, then I write those 2 things and I put a plus sign and then a minus sign. So the trick is just figuring out what things are getting squared. It's always useful to know what your perfect squares are, because those are the numbers that you're going to be looking at and be like, wait a second, I might have a perfect square here. So 144, I know that that is 12 times 12, right? So this is really 1 over 12 that's being squared. And both of these exponents here are even. If all of your exponents are even, that means you do have something that you're getting squared to create that. And to find the thing that you're squaring, what squared gives me r to the 6 s to the 4. That's the thing that I'm looking for that I'm going to put inside parentheses right here. An easy way to do that is to take your exponents and divide by 2. So that's r cubed s squared. R and s. Whatever. Anyway, so here's my a. Right, here's my a squared minus b squared, where this is my a and this is my b. Okay, so that's going to be a, b, and one is a plus and one is a minus. It doesn't matter what order that you're going because it's all getting multiplied out. So that's going to be 1 over 12 and r cubed s squared, 1 over 12 r cubed s squared, one's a minus, one's a plus, and that's it. This guy here, this next guy over here, these both things are squared, right? This is 4x squared, and this is 1 squared, but there's a plus sign in the middle. This is called prime or non-factorable. We can't touch that. We can't change that in any way, shape, or form. All right, moving on to our next pattern. We have a sum of cubes. Perfect cubes are important, not quite as important as your perfect squares because you don't see these as often as you see difference of squares, but you do see sum of cubes and difference of cubes sometimes, so it is useful to get these in your mind. You're like, oh wait, I see 64, that is 8 squared, but it's also 4 cubed, so I need 8 squared, yeah. Anyway, so just things to keep in mind as you're looking at different numbers. So here I have 8f cubed. So 8f cubed, that's really 2f that's being cubed to create the 8f cubed. You can also, and then we have 728 m to the 6. So 729, that's down there. Let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Aha. So the 729 m to the 6 is going to be 9 m squared that's getting cubed. So let's put those in our thing. So we have 2f cubed plus 9m squared cubed. Okay, so our pattern says that if we have something cubed plus something else cubed, that's going to become the two things added together. And then we do this goofy pattern over here off to the side. Okay, so let's go ahead and do that. So this is my A, and this is my B, or my X and my Y, as it were. So let's make that just a little bit bigger so it's the same as everybody else. There we go. All right, so we do the two things. So we have 2f plus 9m squared. And then we do the first guy squared. So that's 2f squared plus the two things multiplied together. So 2f, 9m. Whenever you're doing substitution like this, it's always useful to put things inside parentheses when you're placing them into things. Otherwise, you'll forget that you're like over here. We need to square the 2 and the f, not just the f. So that's a common mistake that people make, is that they don't square everything. So that's going to give me 2f plus 9m squared times, I need to remember to square the 2, 4f squared. And then I need to multiply these guys together, so that's 18fm squared, right? Right. This is squared. Plus 81m to the 4th. Woohoo! That's that. All right, so my next guy up is the difference of cubes. Now, really quickly, before we get going very much further, I do want to compare these two. Like, what is the difference between a sum of cubes and a difference of cubes? And in our patterns, the main thing is whatever the sign is here, we're going to keep the sign in the solo parentheses, and then we're going to change it when we get over here. So notice over here, we've got a minus sign. We're going to keep the sign in the first set of parentheses, and then we change it over here. This guy is always just plus. It's always plus y squared. So that's just kind of some things to keep in mind as you're going through things. So we have a difference of cubes now. So let's see. 125 is actually 5 cubed. And then we have 8v cubed. So that's really 2v that's getting cubed. All right, so I've got 5 cubed minus 2v cubed. So I need to follow my pattern. So I'm going to do 5 minus 2v, and then 5 squared minus 5 times 2v plus, oh wait, no, that's a plus, plus 2v squared. All right, so we have parenthesis 5 minus 2v, and then this is 25 plus 10v plus 4v squared. Now, one thing that some students will do is they'll take a look at this and like, oh, I should keep trying to factor this. No, if you have a difference of cubes, this is how this thing factors. It does not get any more simplified unless you had a GCF or some other thing that you could have factored out at the beginning. But once you go through the difference of cubes pattern, it is factored as much as it can get factored, unless like this is a difference of squares. But that's about it. So yeah, just something to keep in mind as we're going forward. All right, last but not least, we also have perfect square trinomials. So perfect square trinomials, there's kind of two different forms. You have a squared plus 2ab plus b squared, or you can have a squared minus 2ab plus b squared. The most important thing to keep in mind is that these guys are squared, these guys are squared, they're always pluses, and then you've got this central term in here, it's always 2ab. Right here, this is what tells you what goes right here. So if you have a plus in front of the 2ab, you have a plus b that's getting squared. If you have a minus in front of the 2ab, it's a minus b that's getting squared. So right here, right off the bat, I've got this minus sign that's right here. Okay, so this looks like our standard little trinomial, and the patterns that we're going to talk about in just a minute about trinomials always work, but sometimes seeing that something's a perfect square trinomial can save you time. So real quick, this guy here, this is my x that's getting squared. And then this guy over here, this is 3 that's being squared. So now we're going to check to see, is it a perfect square trinomial? We're going to do 2 times a, which is x, times b, which is 3. So if I multiply these all together, I get 6x, which is my middle term. Yay, it is a perfect square trinomial. So that means I'm going to take x, I'm going to take 3, and I'm going to put a minus sign in between them and square it. And that's a perfect square trinomial. So checking this guy over here. Running out of time. So this guy, this is 2x that's getting squared. This is 5 that's being squared. So then I need to check 2 times 2x times 5. All right, so I got all of that. What does that turn into? 20x, which is what I have in the middle. So I'm going to grab that symbol. That's my important symbol. Something plus something getting squared. First something is 2x, and the second something is 5. Bada bing, bada boom, we're done. All right. This is a great spot to pause the video, stretch, take a little break, brain break if you need to, and then we're going to keep going. All right, welcome back if you took a break, and here we go. Let's get going on this last little set, or the second to we're halfway through. All right, so we're going to talk about factor by grouping. So how factor by grouping works, it works only if you have an even number of terms. So you can't do this for those things that we were playing with at the end there where there were 3 terms. That doesn't work. You have to have 2 terms, and 2, or usually 2, you've got a difference of squares and you're looking for a GCF. So you need groups of 2, but more than one group of 2. So like 4, or technically you could do this with 6, but it's usually done with groups of 4. And you're going to put parentheses around pairs of terms, creating groups. Make sure that you pull subtraction signs into the group, not just leave it in between the groups. So like this guy right here, this is going to become, this is negative 10r with a plus sign out in front of him. Okay, he's not, so that's just that's how you got to think about these guys. And then you're going to find the GCF for each group and factor that out. And if groups are all identical, the stuff that you have left inside the parentheses after pulling the GCF out, then you can go ahead and finish factoring by treating that as a new GCF. So let's start working through one. So we're going to put parentheses. So we have 6r cubed minus 9r squared plus negative 10r plus 5. So there's my first step. We pull the subtraction into the inside, and now we're going to look for a GCF on both of these guys. So over here, I can see that I have an r squared, because r cubed is bigger than r squared, and 6 and 9, those guys are both divisible by 3, so I'm going to pull that out. Now when I pull a 3r squared off of this one, 6 divided by 3 is 2, and r cubed divided by r squared is r. Another quick way that you can check for what's left inside is you can set up, oh, we haven't talked about those yet, but anyway, you can set up a fraction, like so, and then you can simplify the fraction, and that's what's left on the inside. So that's another way that you can check that. We keep the sign, minus, and then we're going to see what's left when I pull out the 3r squared from here. That's just 3, so we're going to put a 3 right there. All right, and now we go looking for our GCF over here. My first term is negative, so I'm actually going to pull a negative number out as my GCF. But Ms. Norton, they're not both negative. Yeah, but it's fine. We'll just pull out a negative. We'll pull out a negative 2. So if I have negative 10r over 2, that's going to give me negative... No, not 2, 5. What was I thinking? 5 is not even. So there we go. Pull out of the 5, and that gives me negative 2r. Or no, pulling out a negative 5. Positive 2r. There we go. And then we've got 5 divided by negative 5. That's just going to be negative 1. And minus 1. Okay. That's a 15. Derp. So then let's make this a 15, and that's a negative 3. And this is a minus 3. My bad. There we go. Now this is the same as this. So that becomes my new GCF that I'm pulling out. So I'm pulling out 2r cubed r 2r minus 3. And so after I take this part off, what's left is right here. So that's 3r squared. And then when I take this part over here off, what's left is right here, minus 5. And there we go. Bada bing, bada boom. We have factored this guy via grouping. And that's just how it works. And I'm going to go ahead and not just do the one example for this one, so we have time to make sure that we hit everything. Okay, and that's that. So now we're going to talk about everybody's favorite, the quadratics. Okay, so the easiest ones are when we have a leading coefficient of 1. These are usually written as, or classified as a equals 1 because of ax squared plus bx equals c. So we're looking for a pair of numbers whose product is the constant and whose sum is the middle linear term. So this is my this is my constant. So I want to multiply to this, and I want to add to this term. That's the objective. Multiply to make the number by itself, the one that has no variable, add to make the number with the variable with the lower exponent. So we're going to replace the middle term with the pair of numbers that we get that fits this role, and then we're going to use factor by grouping. So real quick, coming back over here, I'm looking for things that multiply to negative 30 and add up to negative 13. So the method that I was taught when I was in school is I write a negative 30 over here, and I write a negative 13 here, and then I'm like, okay, well, let's see what numbers multiply to make negative 30, because there's a whole bunch that'll add up to negative 13. So let's focus on the multiplication, because that's usually a smaller set of numbers. So we've got negative 1 and positive 30, though, let's see, what would that add up to? That would add up to 29. No, that's not what I want. Negative 2 and 15. That would add up to positive 13, but I'm looking for negative 13. So what happens if I swap the positive and negative? That would give me a negative 13. So I'm going to rewrite this as m squared minus 15m plus 2m minus 30. So notice that these two right here, if I combine them up, they would create, or combine my like terms, they would create a negative 13m. So that's exactly what we're looking for. So now we're going to do factor by grouping. Foop, 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 foop. And we're going to pull out an m. We're going to left with m minus 15. And we're going to pull out a 2. And we're going to left with m minus 15. Foop, foop. M minus 15 times m plus 2. Boom, done. All right. So over here, I do need to talk about this guy because he's a little weird. Ms. Norton, that guy's not squared. He's not a quadratic. He's x to the 4th. Yes, yes, yes. But same basic principles apply. I'm looking for something that multiplies to this, negative 20, and adds up to this. But there's no number there. But whenever there's not a number, there's a 1. if we're talking about multiplication. All right, so then some people do this X method that I've seen. So they're like, okay, well, let's see. Does -2 and 10? No, that doesn't add up to 1, so that's not what my thing is. How about -5 and 4? Well, that adds up to a -1, so what if I just change the signs on those? Ah, there we go. And we've got x to the 4th minus 4x squared plus 5x squared minus 20. And then we go looking for our GCFs. So that gives me, I'm going to pull out an x squared here. And then this is x squared minus 4 plus 5 times x squared minus 4. And that's x squared plus 5, x squared minus 4. There we go. Now, this one is not completely factored yet. See if you can figure out why. All right, but we're going to move on. The leading coefficient is not 1. This is also usually mentioned as a does not equal 1. Is another way that this is a method. There's two different methods of doing this. The first one I call the traditional method because it's the one that I learned when I was in school. Therefore, it's the traditional method. You're going to multiply the leading coefficients and the constant, and you're going to find a pair of numbers whose product is your new number that you've created, and whose sum is the middle term. And then we're going to replace the middle term with the numbers, and we're factor by grouping, just kind of following the same process we did up above. We just have a new target number that we're trying to multiply to. And then there's this other thing called the slip and slide, and I'll talk about that when we do that as an example. So first off, let's do the traditional method with this guy. What we're going to do is we're going to take this guy and this guy, and we're going to multiply them together. That's my A and my C, or my first and my last coefficients. So 2 times -7. That's going to give me -14. And that is not how you write 14. So I'm looking for a pair of numbers that adds up to -14, that multiplies -14, and adds up to -13. You know what? I bet you 1 and -14 would get me to -13. You could also try to, you can try other numbers, and remember, you're multiplying them and trying to find a pair that works. All right, so there's my pair that works. So I'm going to go 2d squared. I always put the subtraction number first, if I can, because that just makes the factor by grouping look a little cleaner when we go to do that. So we're going to factor by grouping, because I don't have to worry about trying to avoid the plus or the minus that's right there. All right, so factoring this first guy, we're going to pull out a 2d for d minus 7. And then here, Miss Norton, there's nothing that those two guys have in common. They're relatively prime. That is correct. And when there's nothing that they have in common, you can always factor out a 1. Because you can multiply anything by 1 and you get the same thing that you started with. So we can write a 1 d minus 7 out front here. So now my d minus 7 and d minus 7, I have those guys in parentheses. So that's my GCF that I'm pulling out. And then I'm left with over here a 2d, and then over here a plus 1. So we got 2d plus 1, and that's how that works. Okay, so that's that method. The other one is called the slip and slide, and this is one that I've learned relatively recently. What we do for the slip and slide is we slip the leading coefficient to the constant by multiplying, and then now our leading coefficient is 1. So we can go back up above and do like we follow the exact same process as we did before, but then at the end we have to remember to divide the number by the number that we multiplied at the beginning. So this one you have to be mindful and remember. Let's color this orange. We're going to take this number. Oh, by the way, that should be 9. Your notes are correct. That's a 9, not a 90. And then we're going to multiply this over to here. So that leaves me with g squared minus 21g plus 90. Yes?
So, one down for TV time for now. What should I do for my TV break?
I don't know. Why don't you go ask Dad?
You tell me.
No, you go ask Dad.
No, you tell me.
No, Keelan, I'm in the middle of recording something right now. Go ask Dad. Keelan. -30.
Set a timer on this. So for half of 1 hour.
Go ask Dad.
I'll just do my idea.
How about you go talk to Dad?
No, I want to do my idea.
Go ask Dad.
No, that's my idea, okay?
No, I'm not approving anything. I'm currently in the middle of recording.
But I would do my idea, though.
You can, but that doesn't mean you get more TV time unless it's approved by Dad first. Okay. And choopity. Uh-oh. We're going to have to rewrite this one because of that minus sign that's right there. All right, so the process I was going through there while I was having negotiations is I was looking for numbers that multiplied to 90 that added up to negative 21. So since my multiply number was positive and my adding number was negative, I knew that I needed two negative numbers that was getting multiplied together. And I just kind of started with 1 and worked my way up. So 1, 2, 3. I don't know if 90 is divided by 4. I know it is divisible by 5 because anything that ends in a 0 or a 5 is divisible by 5, but that didn't work. So the next thing up was 6. We gave 6 a shot, and 6 happened to work. So that gives me this beautiful thing. And so now we need to go looking for a GCF. We're going to pull out a negative, oh, no, just a negative G. Foop. And that gives me G minus 6. Oh, I need to pull out a negative. I'm going to take a stab in the dark and try negative 15. And that's going to leave me, hey, what do you know, G minus 6. So now I can pull out my G minus 6. Some of you guys, why did I pull out a negative G? May know a shortcut for this particular area, and by all means, use any shortcuts you know. All right, so here, this is it, and then people like to get up and just walk away from this point, but you can't. You have to finish the slip and slide. So we've done the slip, we've done the factoring, and now we need to do the finishing part. Way back at the beginning, way back up here, I multiplied by 10. So now I need to divide by, so this was a multiply by 10. Now I need to divide by 10. So this is going to give me G minus 6 over 10 and G minus 15 over 10. What I'm going to do is I'm going to simplify these fractions. I know, fractions. Everyone's like, ugh. No, not the fraction method, anything but the fraction method. Yeah, but there's some people's brains where this just works really, really well. And now we're going to slide. We're going to slide our denominators so that they're in front of the other thing. So that gives me 5G minus 3, 2G minus 3. Bada bing, bada boom. Now I have something that when I multiply them together, I'll end up back with my original polynomial that I started with. But Miss Norton, that's really confusing. Okay, well if this confuses your brain, forget about it. Go back over and use this other method, or method number 1. Some people really like slip and slide. Some people really like traditional. Some people don't like either. We'll pick one and stick with it. All right, so last but not least, we need to talk about factoring completely. Come on, up. Thank you. All right, keep going, there we go. All right. So the first thing you always do is you go looking for a GCF, because hopefully there's a GCF you can pull out and it'll make things simpler when you go for factoring the rest of it. And then you pick a method based on the number of terms that you have. Do you have 2 terms? Well, then we're going to be looking at patterns. Difference of squares, sum of cubes, difference of cubes. If there's 3 terms, then we're either looking at a perfect square trinomial, maybe, or it's a quadratic and we're going to follow the process that we just talked about. If there's 4 terms, then we've probably got a factor by grouping going on. So this guy right here, just running through him really quickly. If we have 3 terms, but we always check for a GCF first. So they all have a k. So let's pull that out. J to the 4th plus 3j squared minus 28. So now I'm going to kind of ignore this guy on the outside. He's going to come along for the ride, but he's not part of my process anymore. So now I'm looking for, let's see, I've got 1, 2, 3 terms. So this is a quadratic type of pattern that I'm looking at. So what multiplies to negative 28 but adds up to positive 3? So let's see, what could this be? 28 is a 4 and a 7. Ooh, and if I made the 4 negative, that would multiply to give me a negative 28 and add to be a positive 3. So we're going to have the k, and then we're going to go j squared minus 4, j squared plus 7. Oh no, I'm not done. You always have to keep checking. All right, right here, this is 2 terms, so this might be a difference of squares, sum of cubes, difference of cubes. This exponent is a 2, so it's going to be a difference of squares if it's anything, but I'm not subtracting, so, okay, that guy's factored completely. He is now also just coming along for the ride. This guy here, uh-oh, I've got something squared. I bet you, yeah, 2 squared, j squared, and I'm subtracting. This is a difference of squares. So What's the difference of squares this guy? We're going to have a k and a j squared plus 7, and then j plus 2, j minus 2, and that's that. All right, this guy up here, this is just 4 terms. I don't see a GCF. These two are even, but this guy isn't, so I can't factor out a 2. So this would just be factor by grouping. And then this guy, let's start with the GCF, is 576 divisible by 9. Please, oh please, that would make life so much easier. So 6 minus 54 is 36, 4, yay! So we're going to pull a 9, and we're going to lift with y to the 6 minus 64. I feel like this is going to be a difference of squares. It might be a difference of cubes, but I know it's a difference of squares, so I'm going to start there. So we've got y cubed minus 8, and y cubed plus 8. It's a difference of cubes and a sum of cubes. We're going to have to follow both patterns. Thankfully, everything's all the same. So let's see, we got 9. Let's see, the pattern is subtract them, and then add, and then last guy's always plus 8 squared, which would be, no, 2 squared. 2 squared, these are 2's, because this is 2 cubed. Ah, silly me. 2y plus 4, because it's 2 squared. And then we're going to do y plus 2 times y minus 2y plus 4. Wah! That's so weird. Anyway, boop, there we go. All right, so one thing that you really need to know is that factoring is never, ever going away. Make sure that you've plugged this stuff into long-term memory. If you don't, practice. Find some Delta Math, some Khan Academy, something. Practice this. Factoring is not going away for the rest of your mathematical lives. Our next video, we'll be talking about rational expressions and how to simplify those up. Have a wonderful rest of your day, and happy mathing!